My name is Tom Greenaway, and I'm a developer advocate at Google. And today I want to tell you a bit about Google search and indexability, specifically about modern JavaScript websites. And this talk actually, I basically gave something very similar to this at Google I/O earlier this year with John Mueller. So this is kind of like very similar content. If you have watched that talk, I don't think there'll be really anything brand new for you, but it's probably good to just be aware of everything that was mentioned in that talk, because there was some sort of like new, there was basically a policy change that was announced with regards to Google search at that talk. So you'll get to hear a bit about that as well during today's talk. Basically, I'm going to go through a few different things like Google search and indexability, and also rendering patterns, as in the construction of like HTML that is then delivered into the document object model of the browser, and also go over some tools that you can use for like debugging Google search that we have made available, like Search Console and others, and then also just some best practices when it comes to building websites that you want to make sure are indexable by search engines. So actually a long time ago, even before I made games, I actually also made e-commerce websites. And personally, I guess as a developer back then, I felt that there was some like mystery behind Google search and how it indexed websites. And like that kind of came into whether or not, like, why did some websites or some web pages that I built appear in Google search and others didn't, and and what was sort of causing that kind of thing. What was the difference? Was it caused by JavaScript, or lazy loading images, for example? Is that going to cause an issue? And so I want to talk very specifically about modern websites, and what I mean by that is like websites that are often powered with JavaScript in the client side to render the HTML to the page. But before I go into modern websites more, I guess one thing that would be nice to highlight is what do we mean by when we say a traditional website? So I fired up like the Wayback Machine and looked at the Wikipedia homepage on November 13th, 2002. That was the earliest I could grab. And I thought it was pretty interesting, because basically what we look at when websites back then were being built is that they were really very simplistic. They just had like text and maybe some images and some links and some headers and that kind of thing. And that's what I'm trying to emphasize, is that they were just very simple back then. And if there was maybe some JavaScript, it was probably just very cosmetic or something like that. So probably wasn't fetching new content on the page. But nowadays, of course, websites, like modern websites, can be a lot more complex, and they can use JavaScript in non-cosmetic ways. So for example, lazy loading images like the ABC News website here, or constructing HTML on the client that's based on data that's fetched from the server through, say, an AJAX request, like this single page app from WeGo here. Or that could even be stored locally somehow and then fetched at a later time, depending on how complex this single page app website is exactly. So the point is that the web has evolved dramatically. And typically these websites will be powered by like a JavaScript framework such as Angular, Polymer, React, or Vue.js. And I hear that there was a talk earlier today about Angular, so that's really great. Actually, just a quick question: how many people use Angular in the room? How many people use React? Okay, cool. It's about 50-50. Polymer? Okay, that's a lot less. Okay, and Vue.js actually? Okay, cool. How many people use jQuery? Just why does everyone laugh? Okay. I was just really curious. Okay. Obviously we really love frameworks because it makes our lives easier as developers. But the whole point of this talk is that I want to highlight some things that can go wrong, or issues you can encounter when you're using client-side frameworks. So, for example, a lot of these frameworks use a single-page app configuration model, meaning that they use a single HTML file that pulls in a bunch of JavaScript. And that approach can make things simpler. But if you're not careful, these frameworks can be a problem for search engines. So if we take a look at the default template for an Angular project, we can see that it's pretty basic. It has like an image and text and links. And you might be thinking, is this really any different to the Wikipedia article I showed earlier? Like, why would this be a problem from an indexability perspective? Well, if we actually take a peek behind the scenes and look at the initial server-side payload that's delivered to the browser, from the Angular project, we can actually see something kind of interesting here, which is that actually everything I can see on the left isn't there on the right, right? So this is probably really obvious to a lot of people in the room if you're using Angular, that or any framework, I guess, that obviously this JavaScript is actually going to fetch the real resources and pull it into the page after the page is loaded in the DOM. So that's sort of the point I'm highlighting, is that the initial HTML is basically devoid of the real content, and everything is going to get added into that app root, but it's not visible on that initial server-side payload. And yeah, basically, we want to understand what does this mean for the indexability of our websites from the perspective of Google Search. So now I'll talk a little bit about actually how Google Search processes pages and it basically indexes the web. And one important part of this, I guess, or just a crazy fact I want to highlight, is the fact that the web is actually very, very large. We've now indexed or found over 130 trillion documents on the web. And processing that data can be quite difficult because it's obviously a huge amount of information. And I'll touch a bit more on that a bit later. And here's a sort of basic diagram of how Google Search effectively was indexing, say, a traditional server-side rendered page or traditional website. So, we're crawling the web, we find pages, we do some kind of processing, we send that information and put it into the Google Search index. And then also based on that content, we might have found more anchors on the page that we want to crawl as well. And so we feed that back into the crawler itself. But what's actually happening inside this process step, right? I mean, when we fetched a web page from a URL and it was a traditional website, that web page was basically complete upon us receiving it and once it left the server. So we call this construction of the web page the rendering. And there's effectively, actually I want to highlight exactly what I mean by that rendering. I mean the actual construction of that HTML, not the displaying of pixels to the screen based on the document object model. The types of rendering that we can do to do this is really that server-side versus client-side rendering. And then there are other types of rendering which I'll touch upon a bit later in the talk, but there's even like one that's like a hybrid of the two. So if we look at this slide again, we can recognize that that server-side payload of HTML didn't have any content, and instead it was really just the client-side JavaScript that was rendering the HTML to the screen. And so nowadays, what's inside this process step? If the pages aren't completely rendered when they're received, then how does Googlebot cope with this situation? Well, it's probably pretty obvious, right? Obviously, it needs to actually do some kind of rendering in order to handle this. So there's actually a renderer in Googlebot's infrastructure on Google Search that literally renders the page just like a browser would render the page, although with some caveats, which I'll come to in the talk. And specifically, we have a version of Chrome that does this, and it's actually a bit of an older version of Chrome, and again, I'll touch on that later. So it loads the page and runs the JavaScript, and then it spits out the final HTML and adds that to the index as well. And very importantly, we also have a queue here for that rendering time, which drives me over to this point, which is that this is something we kind of tried to make clear at Google I/O, that the rendering of JavaScript-powered websites in Google Search is actually deferred until Googlebot has the resources available to process that content. So that render queue, it's a queue for a reason, right? So pages or URLs that need to get indexed and rendered with especially client-side JavaScript get added to that queue and then dealt with over time. And what might surprise you is that actually it can even get a little bit more complicated in that actually Googlebot does some analysis on that server-side rendered content and then does some additional analysis on that client-side rendering that the render queue and the renderer of Googlebot has processed. And the combination of that work is what's effectively put in the index. So why does this matter? Well, it matters for a few reasons. For example, for time-sensitive content, so like breaking news, or if you're like a news website that has new information that needs to get indexed quickly, then you might be a bit caught out because there might be a delay before your page is going to get added into the Google Search index, because it's going to wait until the resources are available to render that page on the Googlebot side. And that rendering queue can actually it's not just minutes, it's not just hours, it can actually take days until the rendering resources are available. And there are some other oddities in the indexing I'll touch a bit more on this very near the end of the talk, but there are some oddities that we're working on improving and fixing. But for example, that first wave of analysis that I mentioned that's processed on the server-side content versus the client-side content later on, there are some differences. So the first wave of indexing processes the canonical tag, but then the second wave of indexing doesn't actually process the canonical tag. So for example, if you've got a single page app design and you're sending down a payload of HTML, and then you're actually expecting that you should only have to set the canonical tag for the URL in client-side code once the page is loaded, then you might be caught out because it might actually analyze the canonical tag of what was originally delivered from the server and then expect that that is a reference to what it should be in the index for Google search. And additionally, if the user requested a URL that doesn't exist and you attempt to use JavaScript to server 404 page, then that can cause a problem too. So for example, like very similar to the last example, if you've got a single page app design and you don't and you get a URL that's just like nonsense, and that's obviously going to be a 404, but you send down the single page app client-side JavaScript HTML to render on the website, and then that performs an AJAX request and fetches that URL, but then at that point it discovers it was actually non-existent on the web server, and you then say, hey, that's not found, that's 404 content, but you never obviously checked that at the beginning, and you sent down a 200 OK HTTP response with the original server-side payload, then that's going to confuse Googlebot as well, actually. So, for example, in that situation, you could actually double check whether or not the URL is valid before you send down the single page app. So what can we do about this? I'm going to talk about some of the rendering patterns that are available. I already sort of talked about client-side and server-side, and I guess one thing to recognize is that server-side is quite good because it's really guaranteed to get indexed by search. There's not really going to be any confusion with server-side rendering, and there's not going to be any delay. But obviously, single-page apps bring benefits to our users from a user experience perspective if they're able to tap on links or click on links, and then there's like it doesn't have to reload the entire page, and it fetches just the content that's going to change, right? So it would be cool if we had a balance of the two and we were able to combine them. And so we call that hybrid rendering. So this is where we send down a complete pre-rendered or server-side rendered version of our page to the user, but then we have additional JavaScript on the client that can handle like AJAXing or navigation around the page and fetching additional resources or additional content. So then it's sort of like got the best of both worlds. And I just want to mention as well, because I did mention Angular earlier and gave the example of how it can cause some problems, but again, like many of the other frameworks have these same issues. There is actually a new feature for Angular called Angular Universal, which is a built-in hybrid rendering mode. So if you're using JavaScript on your server, this can be really useful because then you can share the templating code between the client side and the server side, and you can get that hybrid rendering model out of Angular just very easily. But again, that requires you to be actually using JavaScript on the server, say with Node.js or something like that. So if you're not in that situation, what are you going to do? Because if you've got some other language that you actually construct your templates in on the server, then that means you're going to be maintaining like 2 sets of templates for your pages if you wanted to implement hybrid rendering and have that best of both worlds equation. So what's left is that we actually introduced something new at I/O, a new concept that we call dynamic rendering. And in a nutshell, dynamic rendering is basically the principle of sending a normal JavaScript client-side rendered page to your users and serving a fully server-side rendered version of your content to any search engine crawler or similar client. So this is the policy change that I mentioned earlier. We're basically now allowing this scenario in which you're sending effectively a different resource to Google search versus the users. And we call it dynamic because your site is going to dynamically detect whether or not the requester is a search engine crawler. like Googlebot, and only then send the server-side rendered version of your site. And you can include other web services that can't deal with rendering here too, like say social media platforms sometimes try to, we'll actually like look at a page's content and download it when the URL is shared, and then like, you know, basically create a mini snapshot of that page, like glean some important information like an image and the title of the page. But if you're relying on client-side rendered content to do that, and they don't handle that on their side, then that's going to leave a gap in terms of that information being presented to the users in the social media platform. And for other requesters, like your regular users, you serve your hybrid or client-side driven code. So this gives you the best of both worlds, just like with hybrid rendering, and allows you to migrate to a more performant hybrid rendering for users over time, potentially. But this is not a requirement for JavaScript websites to be indexed. And as you'll see later, Googlebot can render most content already. And for dynamic rendering, our recommendation is to add a new tool or a step in your server infrastructure, such as a dynamic renderer. And this reads your normal web content and handles the client-side rendering, and then sends that pre-rendered version to search crawlers and others. So you might be wondering, okay, but how do I implement that? Well, there are a couple of tools available. One is Puppeteer, which is basically a Node.js library that wraps a headless version of Chrome, and you can programmatically basically access some content and, like, say, access a URL or some content that would otherwise just be is going to be delivered down to the client to be rendered on the client, and actually render that in Puppeteer, and then send that down to the client or to the search engine crawler. And another one is Rendertron, which can be run as a software as a service to render and cache your content. So Rendertron underneath is actually using Puppeteer as well. Both of them are open source, so you can make your own version or something similar made, or use something similar made by others as well, if possible. And for more information, actually, there is another I/O session that was recorded early this year in May, very specifically on headless Chrome, and I think it was given by Eric Beidelman. So that's definitely worth checking out if you want to learn more about Puppeteer. But either way, you need to realize that rendering your pages can be pretty resource intensive. So you may want to do this, say, out of band from your normal web server processing, and implement some kind of caching to reduce the load. So here's just like a quick overview of what this might look like. So Googlebot and, say, those other social media clients that I mentioned might ping to your web server, and your web server would actually consult with the dynamic renderer to get a version of your site that is already client-side rendered, and spit that down to Googlebot and the social media platforms. So that would give them a complete dynamically rendered version of the HTML. And then the rest of your users will actually just get the regular HTML that would be used for client-side rendering. And if you think about it, this would solve the problems I mentioned earlier, because we want, now we can be confident that the important content of our web pages is available to Googlebot when it performs that initial wave of indexing that I mentioned. But of course, how would you recognize Googlebot's requests? Well, the easiest way is to use the user agent detection and look out for the Googlebot string in the user agent. And you can also do other things like a reverse DNS lookup to confirm that that really is a legitimate request from Googlebot. And yeah, I touched on this earlier a little bit, that Googlebot is using a headless renderer to actually render those pages on the render queue. And specifically, it's Chrome 41, which you might realize or remember that that's actually, I think we're now at Chrome 70. So that's a few years old now, and it has some differences with the latest version of Chrome. So for example, it doesn't support ECMAScript 6 or ES6. So things like arrow functions aren't supported, and a few others. So you really want to check caniuse.com and compare some of the features with Chrome 41 to be aware of like the differences between what Googlebot can render versus what your users are probably able to render. And you can use things like Babel to like transpile your ES6 code down to ES5 in that situation. And so you might be thinking, okay, well, that sounds like a lot of work. And since you said that, and since I said earlier this wasn't always required, you might be wondering, when should I actually use dynamic rendering? So here are some common situations. One is that one I touched on earlier, which is that if you have a large and quickly changing website, say a news site that requires quick indexing, as I showed earlier, rendering is deferred from indexing. So for large websites, this can be really critical. And if you rely on modern JavaScript functionality, as Googlebot uses Chrome 41 to render pages, if you require anything newer, say a prepackaged library in ES6, which can't be transpiled back down to ES5, then dynamic rendering can help you. That said, we continue to recommend using proper, graceful degradation. Oh, oops. And finally, this is not a search-specific problem. As I mentioned earlier, like social media platforms and other services might not be able to handle this well on their client side. So I think I tested something with WhatsApp at one point, and I found that a website that was rendering using a framework that expected to be able to render in the client, then actually when I shared that URL on WhatsApp, it sent it to a friend, but the title of the post was like this post title or something like that. So it was actually just exposing the variable names of the client-side framework across WhatsApp. And so when should you avoid using dynamic rendering? Well, the main aspect is really balancing that time and effort needed to implement and run with the gains received, right? So remember that in addition to implementation and maintenance, dynamic rendering can be maybe a significant cost on your server resources. So if you see that Googlebot is able to render your pages properly and you're not making, say, critical high-frequency changes to your website, then relying on Googlebot's rendering is probably just fine. And most sites should be able to let Googlebot render the pages for them, and rendering will just improve on our side over time because we're working on this issue. Now I want to talk a little bit about some of the tools that are available for diagnosing Googlebot's rendering. So, okay, diagnose by version, yeah. So when diagnosing rendering, we recommend doing so incrementally. First by checking the raw HTTP response and the rendered version of the page, either on mobile or mobile, like just on mobile or both on mobile and desktop if you serve different content. And so we can take a quick glance at all of these. The basic information, the HTTP response, is available through a tool in Google Search Console. To gain the access and to use the other features of Search Console, you first need to verify your site there. And there are a few ways to do this. It's pretty fast and easy. Actually, quick question. How many people use Google Search Console? Okay, interesting. How many people knew about Google Search Console? Wow, okay, that's really interesting. Okay. So you should really check out Google Search Console if you're building websites, because it might make you more aware of some of these issues from a indexability or Google search side. So to gain access, like I said, you have to verify your site there. It's very straightforward. It's like you add, there's a few different ways, but one of the easiest ways is just add a particular file to your website to prove that you own that website or have access to editing at least. And we highly recommend doing that for basically all websites. Once you have the site verified, you can use Fetch as Google in Search Console to request a URL as Googlebot, and when it's complete, it will show you the HTTP response codes and as well as the HTML that was returned. So this is a great way to double check the response, especially if you're using dynamic rendering to serve pre-rendered content to Googlebot. And another tool that's really cool is the mobile-friendly testing tool. So once you've checked the raw response, I recommend checking how the page is actually rendered as well. So that tool, mobile-friendly testing tool, can do this. This tool is really fast for checking Googlebot's rendering of a page. And as the name suggests, it shows the mobile version. And as you might know, over time, we'll be actually indexing all content primarily with the mobile Googlebot user agent. So we call this the mobile first indexing initiative that we're moving over to. So it's a good to focus on the mobile version for testing. And we recommend testing a few pages from the different templates of your website. So if you've got an e-commerce site, you probably want to check the home page, like a category page, a product page, and a search page, but you don't need to necessarily like run your test across, all 1,000 products or 10,000 products on your website. You just want to make sure that those key templates are rendering fine. Because if your page is rendered there well, then the chances are that Googlebot will render fine across all the pages on your site for search. A downside here is that you only see the screenshot, so you can't confirm that the rendered HTML is good. So how can you check the HTML? Well, at I/O, we introduced a new way to review the HTML after rendering. So this shows you what was created after rendering with mobile Googlebot. It includes the markup for links, images, and structured data and other invisible elements that are findable on the page. And the rendered HTML is critical for double checking that Googlebot is able to see all of the content that was meant to be shown to your users. But what do you do if the rendered page just doesn't work at all? Well, you're in luck, because we also launched at I/O something that allows you to get full information about the page loading issues as well. So this was like another requested feature for Google Search Console to implement. And as you can see, it gives you a list of the resources that were even blocked by robots.txt on your side. So if you're, actually we encountered an issue like this when we were building the Google I/O schedule website, where we were actually relying on another server to provide us with some like JSON data that we were then rendering into the page for the schedule. And it turned out that actually there was like a robots.txt issue that we didn't notice when we were building it locally. And we discovered it when we were when Googlebot was fetching the resources. And according to the robots.txt of that other service that we were relying on, we weren't actually able to get that JSON data. But Googlebot's logging and error handling here was able to actually alert us to that fact. So it can be really great for picking up on situations just like you wouldn't really be able to notice locally while developing. And when pages fail to load in a browser, I'd check the developer tools, of course, if I was actually like developing locally. So also at I/O, we added a JavaScript console output for what Googlebot gets to see. So if there are errors in the JavaScript, you actually get those now in Search Console, which is kind of awesome, right? Because there might be differences between the errors that you're going to receive in Chrome 41 and the renderer that Googlebot is using versus what you're testing on your local machine. But what about desktop? Well, all of these diagnostics are now available in the Rich Results tool, where we process the desktop rendering of a page as well. So this tool is meant to give you the insight on how Google Search would be able to extract rich result information from a page. And that's elements like the review stars or recipe cards. So if you're curious about that, then there's actually also a code lab for structured metadata that you can check out. And you can use it on pages without structured metadata as well if you want just to debug the information. Okay, now I'll go over a few best practices for building websites with indexability in mind. So one key thing, it's basically like the most important thing about the entire web, right, is URLs. So you want to make sure that your URLs are clean. And what I mean by that is you want to avoid things like hash-based routing. So maybe in the past you used like a technique like example.com/hashabout, and that was something that we did process and index and recognize as a URL. But nowadays we actually don't support that technique. And in the interim, we actually did something called hashbang, so hash and then like an exclamation mark, which you might be familiar with. We don't really recommend that anymore. That was sort of like a workaround because we now have a client-side JavaScript API called the History API that basically means that you can alter the URL state without like causing like complete page reloads, and you can intermingle that well with AJAX requests. So the recommendation is to move over to the History API and really have nice, clean URLs, as we would, just like the traditional purely server-side rendered version of the web in the past worked. And when it comes to link and URL discovery, say like crawling for content, obviously we want to know what the URLs are that you want to go over. This is kind of funny because I just realized that I borrowed this from I borrowed this text from a slide that Martin Splitt built for his presentation. And so now that's actually quite different to what I presented at Google I/O. And it says puppers because he was talking all about dogs throughout his entire presentation, and I haven't mentioned dogs at all. So that's like the one slide about dogs in the entire presentation. Doesn't make any sense. So, but basically the point here is that you really want to structure your URL, structure your anchors, in the traditional method that a server-side rendered website would have. So you want just like proper anchor tags, even if you intercept those with JavaScript and then perform AJAX requests on the client side to fetch the content and change it. This is the best way to indicate to Googlebot that these are links that Googlebot can like crawl across and index further and so forth. If you do like this kind of thing with onClick and event listeners and don't actually put the href in there, then we're not going to pick up on those URLs to expand the crawling queue for your website. Now remember I mentioned at the start of this talk a little bit about lazy loading images and that kind of thing. Well, it turns out that these are only sometimes indexable because depending on how lazy loading is implemented, Googlebot may be able to trigger it, and with that, it may be able to see the image URLs. So, for example, if you have images that are above the fold, then Googlebot is most likely going to see those and index them properly. But if you've got images that are below the fold, Googlebot isn't going to like actually pretend to be a user that's scrolling down the page, and so it won't actually fetch those resources, and therefore it won't be able to index them. So one simple approach is to use a NoScript tag in conjunction with your lazy loaded content. So here I have like a NoScript tag that would ensure that Googlebot can see the images even when JavaScript isn't available. And for Google, another option is to use the appropriate schema.org metadata as well. That way you can handle this outside of the HTML body. So as a side note for images, we don't index images referenced through CSS. We currently only index images that are in the HTML image tags and also in the JSON LD structured data as well. So apart from lazy loaded images, there are other types of content that require interaction to load. So with lazy loading images, it's about scrolling the page, and that's the user interaction. But for example, what about content that's loaded in tabs and that's loaded on demand, or like infinite scroll design patterns on websites as well? So Googlebot, again, generally won't interact with the page, so you wouldn't see these. And there are two ways of handling this for Google search. Either preload the content you want to have indexed and use CSS visibility attributes to make it visible on interaction. This allows Googlebot to index the content since it's already loaded, even if it's not initially visible in the UI of the page. Alternatively, use separate URLs that users can navigate to, and then have like anchor tags to represent the tabs that the user is tapping on, so that it's clear to Googlebot that they're separate pages of content. Another thing to be aware of is that Googlebot, while it's very like patient and is very diligently working through, say, those 130 trillion documents that it can find, there are a lot of pages to be crawled, and so it also has to be very efficient to handle all of that volume. So when pages are slow to render or load, Googlebot might miss out on some of that rendered content, so it doesn't actually wait forever if there are, say, like issues with how long the JavaScript is taking to load. So since embedded resources are aggressively cached as well for search, rendering timeouts are hard to be explicitly tested for. And so to limit these problems, we recommend making performant and efficient websites and web pages as much as possible, and avoid things like artificial delays, and also use like speed and rendering testing tools to check what the performance is like for your website. So you can test the page speed using the usual set of tools like roughly test rendering with the mobile-friendly testing tool, while timeouts are a little bit different than used for indexing of the pages. But if the pages do work there in the mobile-friendly testing tool, then that's a good sign that the Googlebot crawler is going to be able to also fetch and process and render the content in the amount of time allocated. Additionally, Googlebot wants to be able to see pages as a new user would see them. So we crawl and render pages in a stateless way. So any API that stores something locally would not be supported either. So if you use any of these technologies, say like service workers, local and session storage, IndexedDB, Web SQL, etc., then that's going to be an issue from Googlebot's perspective. So you need to make sure you use graceful degradation to allow anyone to view your web pages, even if these APIs weren't supported. Okay, well, that was it with regards to the critical best practices. Now I'm just going to circle back and look at some of the things that we discussed today. So, when you're building a website with, client-side JavaScript, i.e. a modern website, and you want to make sure it's indexed by search engines, first double check for proper implementation of the best practices that I mentioned, say like the lazy loading and the anchors and that kind of thing. Then test a sample of your pages. Use the mobile-friendly testing tool and the other testing tools I mentioned to check that Googlebot is actually able to access your pages properly. You don't have like robots.txt issues, and they can actually render the content and that it can see the content that you want indexed. And if the site is large and quickly changing, or if you can't reasonably fix rendering due to, say, the usage of modern JavaScript, consider implementing dynamic rendering if necessary. So, this would basically ensure that Googlebot does receive a pre-rendered version of your page. And finally, if you decide to implement dynamic rendering, then always double check the results and keep in mind that indexing isn't the same as ranking, but generally speaking, in order for pages to be ranked at all, they obviously need to be indexed by Google and understood effectively. And I also just want to highlight that in our the Google I/O talk I gave with John Mueller, John mentioned how we realize this isn't ideal, this situation with Google search. And so ideally we want the render queue for Googlebot to be much faster, and so that there's less need to think about hybrid or dynamic rendering at all. So I don't actually have any updates on that timeline right now, but I just wanted to confirm that we are still working on it, and we're looking to make improvements in Googlebot, like reducing that render queue and also increasing the headless renderer for Googlebot that is being used to process and render the pages to a newer version of Chrome. Also, here are some really great links. So I recommend taking a taking a photo of this slide. So these are a bunch of the testing tools I mentioned, the YouTube page for the Google Webmasters, also the developers, the documentation on Google Search and Search Console. And also you can actually join Hangouts, office hours Hangouts with the Webmasters team and speak to them directly, like John Mueller, Martin, and also Maria. So, and here are Twitter handles if you want to follow myself, but also the Webmaster Trends Analysts, because they're constantly tweeting and responding to people that have indexing issues, and you can learn a lot from just following them on Twitter as well. So again, you should probably take a photo of this slide. And actually, I'll be presenting with Martin at Chrome Dev Summit in a couple of weeks on the latest stuff on this topic as well. Oh, no, I'll go back. There you go. Go ahead. That's fine. Okay, cool. Anyone else? No. Okay. Okay, well, that's everything from me. Thanks very much.